Hi everyone, in this video we're going to sketch the graph of y equals 3 minus 4 sine 2x. So we're sketching this one because it has a reflection and it also has a vertical translation. So you can see here this 3 is a positive 3. We're used to sometimes seeing it at the end, but it is here at the start. It still means that we're shifting the graph up 3. And this negative means we've been reflected in the x-axis. So you do got to make sure that you do your transformations in the correct order. So we do our dilations and reflections before our translations. If it was written differently, and I'll show you in a sec with Desmos why it's not the translation and then the reflection. So here's one I prepared earlier. Let me just go here. All right, so you can see our red graph, and I've just done a sine x, nothing else, no dilations, and just our vertical translation and our reflection. So let me just, so we've got a comparison, just do the sine graph. All right, so here we've got in green our sine x graph. Both the red and the blue graphs have been reflected, but the red graph has been reflected and then shifted up 3, whereas the blue graph has been shifted up 3 and then reflected. So you can see how it's written differently. And we could also, if we were to expand this bracket and had -3 minus sine x, then you could say it was reflected and then shifted down 3. So there, you need to remember there are many ways you can do transform a graph to get the same outcome. Okay, but just make sure that your dilations and reflections are done before your translations. Okay, so it's really important that you read them correctly. All right, so let's move on. And by now you should know how to do your amplitude and your period. So our amplitude for this one is 4. It is not -4. Your amplitude has to be positive. The negative just tells us that it's been reflected. Your period is 2 pi on 2, and that simplifies to pi. And let's do our range as well. So before we started, our range was from -4 to 4. I think my dog wants to go outside. All right, so we've shifted up 3. Sorry, so I'm just thinking, I'm looking at my dog while I'm doing this. All right, we need to multiply it by, sorry, no multiplying. I'm distracted by my dog. We need to just shift it up 3. So we're going to go +3 and then +3. So our range will end up being -1. Sorry, I keep getting distracted by my dog. -1 to 7. Now your the negative, because it happens before your translation, it doesn't affect your range. Okay, so if we have a quick look at the graphs, so I've just quickly put the 4 in here. So you can see the red graph, oops, zoom out. When we reflected it, it doesn't change your range. Your minimum is still -4 and your maximum is 4. If I put a 4 in here, okay, you can see the range is impacted by that reflection as well. All right, so our period is pi. So remember, it doesn't matter where you put it on your scale. I probably would never put it at the end, just in case you had to go a little bit further. So let's just go again. 1, 2, oops, wrong place, 3, 4. And if we want to go in the other direction, we can. Probably shouldn't, because then the video is longer. All right, and we've got pi here. So remember, whatever your period is, and then we split it into 4. So then we halve it, and then we halve that, and then, so basically we're going up by pi on 4 each time. Your graph has been reflected. So if it's easier for you, you can do the reflection and then do the translation, but I'm going to do it all in one go because I think you're quite capable. All right, remember our domain is -1 to 7, so my scale is not the best. So let's say we go up by 3. 3, 6, so 7's probably around here. And then -1 is going to be around here. All right. And you can do your negatives on this side. We'll just do them quickly. Because once you've done the right-hand side, you can pretty much just do the left-hand side as well. All right, and have we got let's do our midline. So halfway between -1 and 7. So, we've shifted up 4, so it's just going to be at 4. Should probably put that in. 4. Oops, that's a bit wonky. You would use a ruler, hopefully. Maybe. Don't really need it to be. Oh gosh, what happened there? All right. So it's a sine graph. So sine graphs still start here. So usually at 0, but we've shifted up 4. Now your negative, instead of going up, all right, we've got to go down. So at this first point, pi on 4, we're going to be going down, and then we go back up. And this is going to be because of my scale, it's not the best. It's not going to look the best graph. All right, I did contemplate deleting it, but no. I'll show you that I made a mistake. It is not going through 4. Oh my God, no wonder it looks wonky. It goes through 3. It went up 3, not 4. I was looking at the wrong number, and this is me rushing. Sorry, girls, hopefully you got to this point and you're like, I knew that. And that's why I probably should edit these videos, but anyway. All right, going through 3, went up 3, didn't go up 4. I knew that because my graph was a bit wonky, and I just put it down to me not being very good with my axes. All right, there we go. Let's start again. So we're starting at 3. We are going down because remember it's been reflected. So a sine graph usually goes up. We're going down. There we go. Going back up. Now, if you want to, you can use because there's no line here for the 7, you can use other dotted lines to help guide you, and for the 1 as well. All right, and then you can just join the dots. All right, so it's been reflected, so that's why it goes down first. And then you can continue it on the other side if you like. All right, just make sure you go down to -1. It doesn't stop at the x-axis. And it should look symmetrical. I mean, if your axis is good, then it should look like a sine graph. All right, bye girls.